Okay, so last time we were looking at dissociation curves. Let's just write that on here. So dissociation, not disassociation. For hemoglobin. Hemoglobin is a molecule which loads oxygen at high concentrations or high partial pressures, and then it unloads oxygen in areas where the concentration or partial pressures of oxygen are lower. And we said that the normal shape is, as on this graph, is an S-shaped curve, because actually once it's let go of the first oxygen, the hemoglobin changes shape, and therefore it finds it easier to then unload the other oxygens. We said this is a sigmoid curve. We also said that different organisms might want different hemoglobins with different affinities. And the first one we looked at was the lugworm. And we said the lugworm has got an L in it, and that moves the curve to the left. And we'd say it looks something like that. Okay? And this has a hemoglobin that has a higher affinity for oxygen. It loads oxygen at lower partial pressures because it lives in somewhere where there's not much oxygen. But we also said there are some organisms that don't have a problem getting the oxygen in, but they need it released into the tissues because they have high levels of respiration. And our example for that was our little shrew, which has a lower affinity. And that moves the curve to the right. And we also said that if you lower the pH in a tissue, what does that do? Well, if you have high levels of respiration, that's producing more CO2, which is going to diffuse into the blood, lower the blood pH a little bit, and that's going to cause the hemoglobin to release oxygen more readily. And we said that that was known as the Bohr effect. So the Bohr effect also would move the curve to the right. When you're answering questions about dissociation, you need to make sure you use terms affinity, loading and unloading, and so on. Now, some questions will talk about how much oxygen would be released, or extra oxygen would be released. Let's say if this is pH 7.2 and this was pH 7.4, at a given partial pressure, let's say 8 kilopascals. So we can say that was 52, and then that was 20. So you look for the difference. You look for the difference between the lines to say that an extra 32% of the oxygen would be released. I hope that graph's not too confusing. If there are any questions, just contact me.